This is the warm-up for Lesson 29, Graphing Review. Write a true statement about the characteristics of the three lines. So take a second and try and do these two problems. We can see pretty immediately that all the lines have the same y-intercept. So they've got the same y-intercept. They all look to be meeting at -2. It looks like, if I numbered these 1, 2, and 3, it also looks like 1 and 3 might be perpendicular, but it's too hard to tell actual points here to tell, so we'd say definitely they have the same y-intercept. Which ordered pair is a solution to the inequality? So we're just going to plug in. Hopefully our answer is A, so we don't have to do too many of these. But we plug in, so let's do the first one. We're going to say 3 times x plus 10 times y, and see if that's greater than or equal to -1. So our first one, we'll plug in a 1 for x and a -3 for y. And 3 times 1 is 3, and 10 times -3 would be -30. And 3 minus 30 is -27. So is -27 greater than or equal to -1? So this one is a no. Next we'll try and do B. Hopefully that one works. So we'll plug in a -7 for x and a 2 for y. And 3 times -7 is -21, and 10 times 2 is 20, and -21 plus 20 is -1. Is -1 greater than or equal to -1? No, that's a yes. -1 is equal to -1, so this one works. Good. Homework questions we'll do in class. Today we're going over Lesson 29, a review of graphing. So what have we learned so far? So first, we learned how to graph using the x and y intercepts. So graph by finding the x and y intercepts. Then we learned about slope. Remember, change in y over change in x. We called that rise over run. We had a fancy equation that was y2 minus y1 over x2 minus x1. We said that was also denoted by the letter m. Then we learned about slope-intercept form. Slope-intercept form. That's y equals mx plus b, where m is our slope and b is our y-intercept. We learned about graphing linear inequalities. And that was when we had an inequality, so it would be like y is greater than or equal to mx plus b, where we had to do a solid line or a dashed line. In this case we do a solid line, and we shade on top or on bottom. So we've learned quite a bit of stuff so far. So today we're going to practice doing that. So let's practice graphing with the x and y intercepts. So our x-intercept, now you guys should do all these first. If you're watching this on the video, you should try and do this and then watch and make sure that you did it right. So our x-intercept, we're going to substitute in a 0 for y. That's going to eliminate our y variable. So we just have 6x equals 12. we'll divide by 6, and we'll say that our x-intercept is at 2. That's the point 2, 0. Our y value is 0. Anytime we're on our x-axis, our y value is 0. Our y-intercept, we'll substitute in a 0 for x. That's going to eliminate the x term. So we've got 2y equals 12. We'll divide by 2, and we'll get y equals 6. That's going to be the point 0, 6. We're on the y-axis, the y-intercept, and that will be at 6. And we can see we're going from one point to the next, we're going down 6 and over 2. Down 6 over 2. Can that be simplified? Yes, that can. That can be simplified to down 3 over 1, or just negative 3. So that's what our slope is. That's our m value. Our m is negative 3. We can see that our y value, let me draw my line before we do this. Our y value, sorry, our b value, where we cross our y-intercept value, our b, is at 6. So we could rewrite this in slope-intercept form if we wanted to. We'd say in slope-intercept form this would be y equals negative 3x, because our slope is negative 3, plus 6, because our y-intercept is at 6. Finding the slope. So to find the slope between these 2 points, say slope is change in y over change in x. Again, pause this, try and do these two first, then come back. So our change in y, from 5 to go to 10, we're going up 5, that's a positive 5. From negative 2 to go to 3, our change in x, negative 2 to 3, that's going up 5. So 5 over 5, that's a slope of 1. We could say that's 1 over 1 if we wanted to, meaning we're going to go up 1 and right 1. Up 1 and right 1. Now, what do we notice here? We should notice, hopefully right off the bat, that we've got the same x variable. Our change in y is 5 again, but our change in x, from 8 to go to 8, we don't change at all. And anytime we're dividing by 0, our slope is undefined. Now, what happens when we're dividing by 0 graphically? Here's our xy axis. We've got a point at 8, 3, point out here at 8, 3, and a point at 8, 8, that would be above it. That makes a vertical line, and we know that vertical lines have have undefined slopes. We're dividing by 0 because our x values are the same. Graphing in slope-intercept form, so we need to change this equation to be in slope-intercept form. So another way of saying that is just solve for y. Another way would be to write in function form, or to write y as a function of x. So we want this eventually to say y equals. So that means we need to get rid of all this other stuff. Well, I need to identify what's going on. The 2, and this is from the perspective of the y, the 2 is being multiplied. That's multiplication. The x, from the perspective of the y, is being added. That's a positive x. We know it's a positive x because there's nothing out there. If it was negative, it would have a minus sign. So this is addition. The x is being added to the y. So when we're trying to solve for something, in this case we're trying to solve for y, we need to go backwards through our order of operations. So we need to subtract x first. So I get 2 times y equals negative x plus 6. Now, what is that negative x? That negative x is really, there's an invisible 1 there. It's negative 1x. So when we divide by 2, because that's the inverse of multiplication, we get negative 1 divided by 2. That's negative 1/2 times x. And 6 divided by 2 is 3. So we look at this, we say our slope is 3, or sorry, our y-intercept is 3. Put a point at 3, and our slope is negative 1/2. negative 1/2 means we're going to go down 1 and right 2. So down 1 and right 2, down 1 and right 2, down 1 and right 2. If we're going the other direction, we go left 1 and, up 1 and left 2, up 1 and left 2, and we draw our line. Next one, try doing this, graphing linear inequalities. So solve for y and then graph the linear inequality. Again, let's move this down a little bit. Again, we can look at this, and we're from the perspective of the y. We can see that we're multiplying by 2 here. And this is a positive 6x, so we're adding the 6x. So what do I need to do? I need to undo the addition first, so I'm going to subtract 6x from both sides. I'm trying to get this to say y, and then whatever the inequality symbol, I know it's going to be this way. So we got 2y is greater than negative 6x plus 4. We'll divide by 2, divide by 2, divide by 2. Negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. So this is our equation. The symbol is going to tell me two things. First, the symbol is going to tell me that we're going to use a dashed line because we don't have the equal sign. And second, we're going to shade on top because we're eating the y. It's open to the y. We're saying y is greater than negative 3x plus 2. So our y-intercept is 2. Put a 2 point at 2. Our slope is negative 3. That can be written as negative 3 over 1, which would mean down 3 and right 1. So we're going to go down 3 and right 1, put a point. Down 3 and right 1, put a point. Down 3 and right 1, put a point. We can go up 3 and left 1, put a point. Up 3 and left 1, put a point. Remember to use a dashed line. And we're going to shade the top. So the top of this line will be over here. Now, if we were to graph this in using if we just took this equation and we wanted to graph it using the x and y intercepts, then we couldn't just use this because we're eating the y to say we're going to shade on top. So here's what we do. We want to pick out a test point, and the best test point to pick out is the point 0, 0. And then what we'd do is we'd take this equation and we'd substitute in a 0 for x, the point 0, 0. So a 0 for x and a 0 for y. So really what we'd have is we'd have 6 times 0 plus 2 times 0, and see if that was greater than 4. Well, anytime the reason why we use the point 0, 0 is because when we substitute in a 0, we really don't need to do this because we know that it will just end up being 0, because anytime we multiply by 0, we get 0. So is 0 greater than 4? No. So because that's a no, we'd shade on the other side of the line. If it were a yes, we'd shade on this side of the line. So that's how we get around. We make a test point if we're graphing from, this is standard form. So if we're graphing from standard form, use a test point. If we put it in slope-intercept form, then we can use this whether or not we're eating the y, open to the y or not, to say whether or not we're shading on top or on bottom. Our homework tonight is homework 29.